So in this video, I'll discuss how to complete dosage calculation conversions. So dosage calculations work very similarly to dimensional analysis conversions, where you're converting from one unit of measurement or one prefix to another. The difference is that whereas with a dimensional analysis, many of those conversion factors are known and they apply regardless of the situation. When it comes to dosage calculations, you have conversion factors that are available based on that situation. Recall, a conversion factor simply tells us how two units are equivalent to one another. And so they give us that relationship between those different units. And so with dosage calculations, in often cases, we have to use that dosage that is prescribed, or we have to use the concentration of that medication as a conversion factor. And so recall, conversion factors simply give us that relationship, and we can show them as fractions. The way that you write a conversion factor is based on how you would read that conversion factor. It basically tells you what units correspond with what units. And so we'll walk through a couple of examples as we apply the process of completing a dosage calculation. So in this first example, it says that a patient needs 500 milligrams of acetaminophen per day. If the supply comes in 125 milligram tablets, how many tablets per day does the patient need to take? So just as with any other problem, you want to read through and you want to figure out what the information is actually telling you, as well as what are you being asked to provide. So a patient needs 500 milligrams of acetaminophen per day. So that is the dose that this patient has been prescribed, 500 milligrams per day. So the way that you read it tells you how to separate it. So we can show that as a conversion factor, because that tells us the relationship of the amount of medication this person should receive based on the number of days. And so it also tells us that the supply is in 100 milligram tablets. So what that tells me is that for every one tablet, that represents 125 milligrams of that medication. Now recall, again, with conversion factors, I can show it as I just wrote it, one tablet over 125, or I could have shown it 125 milligram over one tablet. I'm simply showing how these two things are related to one another. The question asks, how many tablets per day would the person need to take? So we don't know, but we know we're trying to figure out the number of tablets per day. Now, when you're completing the dosage calculation, again, it's basically a dimensional analysis. Just as with dimensional analysis, you're starting with some given and you're trying to convert it to an unknown. So we're starting with a given and we're trying to convert it to an unknown. With a dosage calculation, you're either starting with the dose. However, if it is a dose that is weight dependent, then we have to start with the weight. In this case, it doesn't tell us anything about weight, so it doesn't depend on the weight. Instead, we're simply focusing on the dose. So that means that what we're starting with is the dosage that was provided, which is 500 milligrams per day. And if we think back to what we're trying to find out, we're trying to find out tablets per day. So we're starting with milligrams per day, we're ending up with tablets per day. So in other words, we have to ask ourselves, is there a direct relationship in this situation between the milligram and the tablet? And of course, the problem told us that the supply that was on hand was 125 milligram tablets. So that meant that every tablet contained 125 milligrams of this medication. And so just as with the dimensional analysis, I tend to do a T-chart, just one long line, one long horizontal line with vertical lines that shows me how to go from the given unit that I no longer need to the unit that I do need. So in this case, the problem gave us a relationship between milligram and tablet, and that relationship was that for every tablet, it has 125 milligrams of medication. So if you're keeping track of your units, our milligrams will cancel, leaving us with tablets per day, which is what the problem asked us for. You were asked to calculate how many tablets per day. And so from there, Because I've already converted to the units that I need, I've gotten rid of the ones I didn't need. Simply put in my calculator 500 divided by 125. And what that tells me is that this patient needs to receive 4 tablets per day. So some dosage calculations are going to be pretty straightforward, where you're provided with the dose, you're provided with the given unit, and you only need to use one conversion factor to go from that given to that needed unit. And so again, the key is just making sure that you're looking at the information that is given and deciphering what that information actually represents. Writing down things will help you to keep track of what was given, what you're needing, and it'll help guide you through that process. So if we look at another example here, suppose that you need a dose of 500 milligrams of a liquid medication that is available in a solution of 250 milligrams per 50 milliliters. How many milliliters should you take? So again, go through and read it. Suppose you need a dose, so it's telling you what the dose is of 50 milligrams of liquid medication. So it doesn't tell us per day, per dose. Technically it does, but it doesn't tell us per day, I should say, but it does tell us per dose because you need a dose of 50 milligrams. So I could write this as 1 dose. So for every 1 dose, I'm going to receive 500 milligrams. The previous example told us how much the person needed a day. This is just telling us the dose. So I could have simply left it at 500 milligrams. I could have written 500 milligrams over 1 dose, or I can write it as it's shown here, 1 dose over 500 milligrams. Because recall, conversion factors, again, we can flip them either way. We're simply showing the relationship. How we flip it depends on what we're given and how we need to go from that given unit to the needed unit. And so it told us that this was the dose. It also told us that it was available in a solution of 250 milligrams per 50 milliliters. And so when you're reading the number, it tells you how to separate it. 250 milligrams, that means that those two things go together. Per tells me how to separate or divide my fraction, and then 50 milliliters goes together. Then the question is, how many milliliters should you take? So I really don't have to worry about that 1 dose. I could have just, again, started with 500 milligrams. But if we needed to know how many milligrams we should take, how many milliliters we should take, I could have also said, okay, so I need this many milliliters per dose. So either way. But you always want to start with the dosage. And again, this one doesn't tell us anything about weight. So it's not weight dependent. So that means that we're starting with the 500 milligram dose. So again, I can put per dose. So each time this patient takes this medication, this is what they should receive. So the goal is to figure out how many milliliters. So you need to ask yourself, can I go directly from milligrams to milliliters? So is there a conversion factor for this? Milligram is a mass measurement. Milliliter is a volume measurement. Is there a way to relate the mass to the volume? And so based on this situation, it tells us that this solution is available as 250 milligrams per milliliter. So this shows how we can relate the mass to the volume. Again, the problem gave us that information. And so with the information that the problem gave us, we have to use those same numbers. The problem told us that for every 250 milligrams, that's 50 milliliters. So again, keeping track of the units, the 50 milligrams have canceled, leaving me with milliliters. So I can determine how many milliliters I need per dose, or this patient needs per dose. So you're going to multiply your 500 times 50, the product of that divided by 250, and that indicates that this patient is going to need 100 milliliters per dose. So every time a dose is being consumed or being administered, this patient needs 100 milliliters if they are prescribed 500 milligrams, but what's available is a solution that is 250 milligrams of medication per 50 milliliters of solution. And so this is how you would complete this dosage calculation. So let's do one more. So here it says a doctor's order for Percocet reads administer 2.0 milligrams per kilogram per day in 2 equally divided doses. If your patient weighs 165 pounds, how many milligrams will you administer in each dose? So this one tells us a lot of information. So again, you want to go back and decipher. Figure out what each piece is telling you. A doctor's order of Percocet reads administer 2.0 milligrams per kilogram per day. So the way you would write that, 2.0 milligrams per kilograms per day. So each day, this is how much this person should receive. It also tells us that it is divided in 2 equally divided doses. So they get 2 equally divided doses every day. So we could write that down as well. We can say 2 doses per day. If your patient weighs 165 pounds, how many milligrams will you administer in each dose? So how many milligrams should the person receive in each dose? And so in this case, the dosage was 2.0 milligrams per kilogram per day in 2 equally divided doses. So the 2.0 milligrams per kilogram is what this patient should receive. That is their dosage. However, this is a dosage that is dependent upon weight. When you see a dosage provided per kilogram, that is a clue that you're dealing with a weight-dependent dosage. So that means that depending on how much this person weighs, that dictates exactly what amount they should receive. They're getting 2 milligrams for every kilogram that they weigh. However, it gave you the person's weight in pounds. So again, when you're carrying out dosage calculations, you're either starting with the dose if it is not weight dependent. If it is weight dependent, then that means you're starting with the weight, because depending on that weight, that will determine the exact dose. So in this case, it is dependent on the weight. So we have to start with that weight. So the person weighs 165 pounds. In order to determine the exact amount that they are receiving, again, it's 2.0 milligrams per kilogram. So we need to know, so what is this weight in pounds? What is the equivalency in kilograms? So we have to convert from pounds to kilograms. So this is a constant factor, a constant equivalency. And so when you're converting from pounds to kilograms, for every 2.2 pounds, that's the same as 1 kilogram. Or you can do 2.205. I'm just rounding to 2.2, and so that cancels out my pounds. So this is going to give me this person's weight in kilograms. From there, I can then determine, okay, so now that I know their weight in kilograms, how much are they to receive each day? And now this is when your dosage comes in. The dosage tells us that the patient should receive 2.0 milligrams per kilogram per day. So I need to get rid of my kilograms so that I'm left with milligrams. Again, based on what we had. So this is why I wrote everything before I even started setting it up, so that I can see what my conversions are. I can see how things are grouped together. The numbers still stay with those units. So 2.0 milligrams per kilogram. Again, my units cancel. No longer have kilograms. So right now, if I were to perform this calculation, I can figure out, okay, how many milligrams should this person receive each day? But the problem asks for how many milligrams per dose. So I have milligrams per day, not milligrams per dose. So what that tells me is that I need to get rid of day. So since day is in my denominator, in order to get rid of day, I need it in my numerator. And I'm trying to figure out the relationship between day and dose. Based on the problem, it told us that this was divided into 2 equally divided doses. And so that means that every 1 day, this patient is going to receive 2 doses. And so that's what information we obtained from the problem. So days cancel out. So if we look at the units that are remaining, we have units of milligrams per dose. From there, you want to carry out the calculation. You want to multiply everything in your numerator. So 165 times 2 divided by the product of your denominator. So that 2.2 times 2, so the product of your numerator divided by the product of your denominator. And when you do that, it gives you 75 milligrams per dose. So this patient should be administered 75 milligrams for each dose. They will get this dose twice a day. So if we were asked how much should they be administered each day, we would have cut out this last step. We just figured out milligrams per day. But because we needed to know for each dose, we had to take it a step further and figure out milligrams per dose. So when it comes to dosage calculations, the key is just making sure that you read through the problem. Sometimes you have to read it and reread it, but look at what that information is telling you and go ahead and write it as a conversion factor before you even start the setup for your dimensional analysis. So I hope this helps. If you have any questions, please let me know. Thank you.